Here's another trig equation that we can solve using our basic reference triangles. Find all solutions of the equation cotangent squared of x minus 3 equals 0. One thing I'd like you to note is just like in algebra, if you were to have an equation where you had one square term that you could isolate, you can apply the square root property. So let's do the same thing here. Isolate cotangent squared, apply the square root property, and we see that we want to find where cotangent is either plus or minus root 3. Now, we can ultimately generalize the solution, but initially let's look at our four quadrants to see what we can tell about where cotangent is positive versus negative. Okay, and just a reminder of the scheme I've given you before. Ordered pairs in the first quadrant, everybody's positive. Ordered pairs in the second quadrant, the signs are unlike, so cotangent's negative. Third quadrant, the signs are the same, so cotangent is positive. Fourth quadrant, the signs are unlike, so cotangent is negative. The reminder is that cotangent in general is defined as the x-coordinate divided by the y-coordinate in those situations. To the right, you see my reference triangle, which the only one of the two we have that has a root 3 is the 30, 60, 90, so that's my first choice to look at. And then we can decide that since cotangent of an acute angle is adjacent over opposite, we will get a value of root 3 when we look at the 30-degree angle, or pi over 6. So in quadrant 1, the solution would be simply pi over 6. In quadrant 2, it's going to be pi minus pi over 6. In quadrant 3, it's pi plus pi over 6. And in quadrant 4, it's 2 pi minus pi over 6. Now if we get common denominators, where pi is 6 pi over 6, this turns out to be 5 6 pi, and this is 7 6 pi, and this is 11 6 pi. Okay, so those are our four solutions between 0 and 2 pi. Now look at the differences between where cotangent is positive. It's positive in quadrant 1 and in quadrant 3. Those are pi units apart. So really, to generate all the quadrant 1 and 3 solutions, I just need to take the one in quadrant 1 and repeatedly add pi. Likewise, if I look at quadrants 2 and 4, those are quadrants both where cotangent is negative. Those are pi units apart. So really all I need to do is take the one in quadrant 2, 5 pi over 6, and repeatedly add pi. So I'm going to look for that in my solution. And I only see one in this list that has both the correct initial generators, and then I double check to make sure I'm adding multiples of pi, and then I make my selection.